welcome to the Explainer. You know, if you've ever been amazed at how something like ChatGPT can follow a really long conversation, or how an AI can whip up a detailed image from just a simple prompt, well, you've actually seen today's topic in action. We are pulling back the curtain on the attention mechanism. It's really the secret sauce that gave AI its powerful sense of focus. So, over the next few minutes, we're going to break this whole idea down. We'll start with a memory problem that had early AI totally stumped. Then we'll get into the elegant solution, attention. We'll even peek under the hood to see how it works, see the transformer revolution it kicked off, and finally, discover how this one single idea is now shaping, well, the entire world of AI.
All right, so to really get why attention was such a game changer, we have to rewind a bit. Before 2014, AI had, to put it bluntly, a terrible memory.
Just think about how our brains deal with a long sentence. We just intuitively know who's who and what's what, even if the subject and the action are worlds apart. But for early AI, this was a massive, massive hurdle. The further it read into a sentence, the more it would just forget what happened at the start.
See, these older models, things called recurrent neural networks, or RNNs, they worked by reading one word at a time, trying to cram all the meaning into a single, constantly changing summary. It was kind of like a game of telephone, you know? The message at the beginning just gets fuzzy and weak by the time you reach the end. So yeah, as you can see here, a short, simple sentence, no problem. But with anything remotely complex, that crucial context from the beginning would just fade away. Researchers had a name for it, attenuation, and it was a huge bottleneck for really important stuff like machine translation or summarizing long documents.
So how do you fix a memory problem like that? Well, the solution was absolutely brilliant and honestly pretty intuitive. You give the AI a new kind of focus, one that was actually inspired by how our own brains work.
So instead of treating every single word equally and in a straight line, the attention mechanism lets the model look back over the entire input sentence and decide for itself which words are the most relevant for the very next thing it needs to do. It literally assigns an importance score to every word.
And this right here, this is where it all clicks. This is attention in action. We're translating I love you into French, je t'aime. The model isn't just going left to right. Check this out. To generate that first French word je, look where its focus is. It's putting a massive 94% of its attention right back on the English word I.
And here's the real magic. To produce the third word, aim, the model's attention completely ignores you. It jumps all the way back to the second word, love, and gives it 95% of its focus. This is the whole breakthrough. It's no longer a prisoner of the sequence. It can look anywhere it wants to find what's most relevant, which completely solves that memory problem.
So, you're probably wondering, how on earth does the model figure out these importance scores? It sounds super complicated, but the core idea is surprisingly simple. It all boils down to three things: queries, keys, and values.
The best way to think about it is like a super efficient librarian. For every single word in a sentence, the model creates 3 different pieces of information. You can think of them as just numerical representations of that word's role and meaning. And we call them the query, the key, and the value.
Okay, so here's how that librarian finds the right book. The word the model is currently focused on sends out a query. It's basically asking a question, like, hey, who's the one doing the action here? Then, every other word in the sentence holds up its key, which is like a label that says, I'm a noun, or hey, I'm the action word. The query scans all the keys, finds the strongest match, and then pulls that word's value, which has all its rich contextual meaning. It's basically a search engine for meaning, right inside the sentence.
Now, what's really crucial here is that it's not a hard choice. It's not just picking one word. The model uses what are called soft weights, so it's blending information from lots of different words. It creates a special context vector that's a weighted average of all the other words, giving it this much richer, more nuanced understanding.
So for a few years, attention was this clever little add-on that made the old models better. But then, 2017 happened. A paper came out with this incredibly bold title, Attention is All You Need, and it changed absolutely everything.
This timeline just shows you how fast things took off. After 2017, researchers had this huge realization. They didn't need the slow, step-by-step part of the old models at all. They could build a completely new kind of AI based only on attention. And that was the birth of the transformer.
And at the heart of the transformer is an even more powerful idea: self-attention. Now get this, instead of just connecting an input to an output, the model lets every single word in a sentence look at every other word in that same sentence, all at the same time. This creates this incredibly rich,
interconnected web of meaning. It's how the model understands grammar and context on a level that is just profoundly deep, way beyond anything those old sequential models could ever dream of.
And because it wasn't stuck processing one word at a time anymore, the whole process could be massively parallelized. That meant we could train these models on gigantic amounts of data, way faster than before. This is the exact innovation that led directly to the powerful large language models, like GPT, that we all use today.
And the shockwave from this big idea didn't just stop with language. The core principle of finding what's relevant has now been applied all across the entire field of AI.
I mean, this same idea of focusing on what's important is now just everywhere. In computer vision, it lets an AI zero in on one face in a massive crowd. In biology, it's the engine behind models like AlphaFold, which uses attention to solve the fiendishly complex puzzle of protein folding. From the speech recognition on your phone to AI art generators, attention is the engine running under the hood.
And this is really why this all matters. This one elegant solution to a very specific memory problem in machine translation, it turned out to be a universal principle for intelligence. It unlocked progress across pretty much every single area of AI research.
You know, when you step back, the core of the attention mechanism is just a beautiful, simple idea. Focus on what matters. And its profound impact just leaves you with this one fascinating question. What's the next simple idea out there, just waiting to be discovered, that's going to spark the next AI revolution?